Eliminating spuriousness is a tricky problem. You got to realize that we live in a multivariate world. We're talking about really simple relationships or theories, X causes Y, but in the real world, there's lots of other variables, and those other variables can really complicate our analysis and really lead to a lot of confusion if we're not careful. The biggest problem here is what we call spuriousness. Spuriousness basically means a false relationship or an illusionary relationship. Let's say that we do some kind of research and we think that this is going on, that X causes Y. We do our research, we find a correlation, let's say a positive correlation, and we find it significant, very unlikely to occur by chance. We do investigation into time ordering, and sure enough, it really looks like the arrow of causation is pointed in that direction. X really is causing Y to change. Now, so far so good, but that leaves open a serious question that we really haven't addressed, and frankly a very tricky problem, the problem of spuriousness. What about the effect of third variables? Sometimes the problem of spuriousness, or false or illusionary relationships, is called the third variable problem. Third variables can sometimes influence the variables that we're studying. They can be correlated with them. Let's consider a third variable. I don't know, let's call it Z. We may think that this is going on when in fact something like this is going on. Maybe after we control for this third variable, this other variable, Z, we might very well find that there's no relationship whatsoever between X and Y. Or maybe a less extreme case is the relationship between X and Y becomes very, very weak after controlling for some third variable. Let me give you an example. Let's say we're talking about, marijuana use and hard drug use. Some people claim that marijuana use leads to harder drugs. Well, they would be basically arguing you'd find a correlation, a positive correlation between marijuana usage and the use of a variety of hard drugs. Let's say you go out, you gather data, and that's what you find, and the correlations are strong, they're positive, they're statistically significant. And you also could do research suggesting that there's proper time ordering. In other words, changes in, people tend to smoke pot first and only begin to experiment with harder drugs later, not the other way around. Now that isn't necessarily true with everyone, but at least in more cases than not, on average, there's a strong tendency for people to experiment with pot first and only later experiment with harder drugs, maybe get hooked on them. That's consistent with the arrow of causation pointing in this direction, pot smoking causing harder drug use, not the other way around. So far it looks like, sure enough, smoking pot leads to harder drugs. It causes it. But maybe appearances aren't what they seem. Maybe what's really going on is something entirely different. Maybe some third variable, like who you associate with, maybe associating with a lot of other people that use illegal drugs, is likely to cause you to be more likely to smoke pot yourself. And maybe the same kinds of association are more likely to get you to try harder drugs as well. Maybe something else, like who you associate with, could affect both X and Y. And after you control for that, maybe there really is little or no relationship between marijuana smoking and harder drug use. Maybe. Perhaps there's other third variables. For example, it might be some kind of variable about your home background, having parents that weren't as loving, as nurturing and supportive. That might make you more likely to experiment with pot, and the same variable might make young kids more likely to experiment with other harder drugs. Maybe it's psychological kinds of variables might be here. So for example, kids that are risk takers, kids that have poor self-control. It's something about their personality, their psychological profile that causes them to be more likely to smoke pot in the first place. And the same characteristics also produce other kinds of drug use, hard drug use. Now, notice, with each of these different explanations, we're simply offering different examples of third variables that might explain away the relationship between X and Y, even though X and Y appear to be strongly correlated in the expected direction. The correlation appears to be statistically significant, even though the time ordering looks right. Maybe, just maybe, X isn't causing Y at all. Maybe it's something else. And that is a tricky problem because you may not know what that other variable is. You're going to have to go out and find it, identify it, do research, and somehow control for that other variable so you can tell whether this is true or that's true. Or maybe whether this is true or that's true. You're going to have to design and conduct your research to figure that out. And frankly, that's going to be a very serious problem because there's no master list where everybody knows what possible third variables there are. In some cases, we have pretty good ideas. In other cases, well, we're very much in the process of trying to figure that out. It's an open-ended question. Now, when we talk about this, I do need to point out that this has strong methodological implications. First of all, you're going to have to design your research to control for as many other variables as you can. And also, you're going to have to use replication. You're going to have to repeat your research, sometimes in different situations, different groups of people, under different conditions, in order to see whether other variables are producing spurious results. The larger implications are that research is an open-ended process. It's never really done. The more variables we control for and investigate, the more, let's say that you do research on, I don't know, again, marijuana smoking, and you do control for the kinds of third variables I talked about. One study after another, you're trying to see whether the correlation between X and Y disappears or at least greatly reduces in magnitude after you somehow control or introduce the influence of third variables. And you study third variable after third variable. And you continue to find, in spite of these third variables, that there continues to be a strong positive correlation between pot smoking and hard drug use. If that were the case, you become increasingly confident that that relationship was real, it wasn't spurious. But again, it's always possible that later on you'd introduce yet another third variable and that relationship would disappear. So what that means is research really is an open-ended process and it's never finalized. You never know for sure whether one variable causes another, although in practical terms you do become more and more confident. Now, one last comment on these topics that we've been talking about. Earlier on I mentioned that correlation is not the same thing as causation. And now we're in a little better situation to explain why that's true. One reason that correlation does not imply causation is that sometimes correlations are, well, dumb luck. That's why we do statistical tests of significance. But there's no guarantee that when we do research, even if we find strong correlations that appear to be statistically significant, it's still possible that those results are just arbitrary flukes. And if we were to do more research in the future, we would typically not find those same results because they aren't really real. So we have to be careful. Just because we find a significant, strong correlation in the expected direction, we have to always realize that that could just be dumb luck. Second, just because two variables are correlated, that doesn't tell us which way the arrow of causation is pointed. It doesn't tell us what's causing what. And finally, just because two variables are correlated in the expected direction, that doesn't deal with the problem of spuriousness. These variables may be related very strongly if you just look at them. On the other hand, once you introduce a third variable, the relationship between those variables may simply disappear. There may be no real direct causal relation between X and Y because both X and Y are like puppets on a string, both of them being caused or influenced strongly by other variables. If you control for this third variable, there's no relationship at all between them, or at least very little relationship. So, why does correlation not imply causation? Because of dumb luck, because of random variation, because it doesn't address the issue of which way the arrow of causation points, And finally, it doesn't control for third variables that might create illusions of causation or create the illusion that there's a causal relation when really there isn't, that the correlation in a sense is misleading. At any rate, next time around, we'll get together and we'll talk about yet another methodological issue, measurement. I'll see you then. Thank you.